Hello, all. In this session, we are going to discuss about the metrics of the clustering methods. So far, we analyzed the clustering methods, right? How the effectively the data points will get clustered by using several clustering methods such as CLHAPI or the hierarchical clustering. Those clustering methods will be able to divide the data points into several clusters. Now, in this session, we're going to understand how those methods actually are performing, how those clustering methods actually are performing. Are those optimally dividing clusters or, it is inoptimal? We're going to find out. Okay, so what is this? Clustering, just a minute. Yeah, clustering performance evaluation is crucial for validating the quality of the clustering models. How well a model is being performed will be analyzed and identified by this performance evaluation. This can be broadly categorized. These metrics can be broadly classified into two categories. The first one is internal performance evaluation. Second one is external performance evaluation. Okay. In internal performance evaluation, we're going to use intrinsic properties of the data and clusters. We're going to use the intrinsic property. In the external performance evaluation, we're going to use the ground truth levels. Okay, now let us see what is this internal performance evaluation. The internal metrics evaluate clustering quality based on the intrinsic structure of the data and the cluster assignments. They do not rely on the external labels. It just completely is based on the structure of the data. Okay, and how this data is being assigned into the various clusters will come under internal performance evaluation. The first one is Davis-Bowden Index. The first one is called Davis-Bowden Index. This is a performance metric. By using this, we'll be able to understand and analyze how well a model is performing, how well a clustering model is performing. Purpose is to measure the average similarity ratio of each cluster to its most similar cluster. By using the Davis-Bowden Index, we'll be able to measure the average similarity ratio of each cluster to its most similar cluster. Okay, there is a cluster X, it's not a data point, now it's a cluster X. There is another cluster Y. Now, we're going to find out a similarity ratio in between X and Y. If there exists Z and A, which also are similar to the cluster X, then we're going to compare the similarities in between X and Y, X and Z, and X and A. Then we're going to identify an average similarity ratio of X and Y, X and Z, and X and A. So for this formula is DPI is equal to 1 by NC, where number of NC is the number of clusters, into where I is equal to 1 to number of clusters, where max J is not equal to I. S of I plus S of J. Okay, so what is S of I? Average distance of all points in cluster I to its centroid. S of I stands for average distance of all points in cluster I to its centroid. Of course, you know what is S of I. What is S of J? S of J is average distance of the ith data point cluster J. Okay, so where Si is the average distance of all points in cluster I to its centroid, where Sj is average distance of all points in cluster J. Okay, then M of Ij is distance between centroids of the cluster I and J. Okay, so this is how the Davis-Bowden index will get calculated. Interpretation is lower values if DBI, Davis-Bowden index, is lower, then it is optimal. It indicates better clustering. If it is a good clustering, has well separated clusters and low intra-cluster distances. Intra-cluster distances are it's not inter-cluster distances, intra-cluster distances, meaning data points are dense together. There will be a lot of dense, collected together data points. Okay, then Silhouette quotient. We already knew what is Silhouette quotient. The Silhouette quotient is equal to bi minus ai divided by max of ai comma bi, where ai is the average distance of I to all the other points in its own cluster. We already discussed this. bi is the minimum average distance of I to the points in the nearest neighboring cluster. Here, what is bi here? For an example, there is a x and there are several data points. Okay, minimum average distance of I. Okay, let us say x. This is I also. Let us say this is I. Just I'm taking I here. Minimum average distance of I to the points in the nearest neighboring clusters. So this is called bi. Overall Sinhalti score means Sinhalti quotient for all samples. If the range of Sinhalti score Si is minus, in the range should be in between, it will be in between minus and 1. If Si is equal to 1, it is well clustered. Okay. If it is minus 1, it is not clustered at all. It is not clustered good. Okay, if Si is equal to 0, that means there's the overlapping clusters. Data point might be the edge of this overlapping clusters. Okay, is less than 0, anywhere closer to minus 1 is misclassified. Okay, the next thing is external performance evaluation. So far, what we discussed about is internal performance evaluation. Now let us focus on external performance evaluation. External performance evaluation clustering qualified using the ground truth labels. Let us see how exactly these ground truth labels are going to contribute towards this evaluation. Now, see, what is ground truth label? Let us understand. See, initially, let's try to find out the rank index. Understand rank index. Okay, the purpose of the rank index is measure the similarity between the cluster assignments and the ground truth labels. So, here, how good, rather how similarly the clusters are divided or grouped. Now I have several data points. Okay, now in order to divide this data point into several clusters, what exactly the similarities that we use? What in the other words, in the other statement, it quantifies the similarity between the cluster assignment. Now I just have taken point X, Y, Z. Now I just going to measure the similarities of assigning X to one group, Y to another group, Z to maybe one or the other group. Okay, the formula for this, defining this rank index is true positive plus true negative divided by true positive plus false positive plus false negative plus true negative. What's the true positive? True positive meaning pairs correctly grouped together. There are several data points. All these data points have been assigned to one cluster, which is rightly identified which is rightly identified. Yes. The next thing is true negative. What is true negative? Pairs correctly not grouped together. What is true negative? Pairs are correctly not grouped together. That means true negative, understand, see, this is not a what you actually think. See, X, Y, Z, these are three data points, and there's the cluster A, cluster B. Okay, these X, Y, Z should be classified to A. Yes, X, Y, Z belong to A. Of course, it's true positive. What is true negative? Now, let us say I have B. Forget about A. None of these X, Y, Z belong to B. So, none of X, Y, Z can be grouped into B, will be assigned to the cluster B. It's called true negative. Actually, X, Y, Z have actually been not assigned to the cluster B. It's called true negative. Okay, I'll take a simple example. Dog. It's not writing. Right? Anyhow, there is a dog. This is a dog cluster. And there is another cluster, not dog. Okay, not dog. I have taken data X, data point X. Data point X is a dog. Okay. Now, when the data point X is being classified into dog, yes, it is true positive. Okay. Now observe X with respect to not dog. Of course, X is not a dog, right? So X will not be assigned to not dog. It's true negative. Pairs correctly not grouped together. Okay. We go to count. Yeah. So this is the total RAND indexes: true positive plus true negative, true positive plus false positive, false negative plus true negative. False positive and false negative is on the other way around. Okay, what is the false positive? Pairs incorrectly grouped together. False negatives pairs incorrectly separate. This is a false negative. Totally it gives you RAND index. The RAND index is RAND index in between 0 and 1. Higher values indicate better clustering. Okay, so the higher values will be it will state that it's better clustering. Next there is something called a Jaccard score. Measure the proportion of the true positive pairs to all the positive pairs. Here there is a Jaccard score, by using which we will also be able to identify the performance of the clustering methods. Yeah, but here it only takes some parameters into consideration: true positive, false positive, false negative. So it just takes the proportion of the true positive pairs to all the positive pairs. Okay, so Jaccard score J is equal to true positive divided by true positive plus false negative. Emphasize the presence of true positive pairs while penalizing the incorrect grouping. Again, it is 0 and 1. Jaccard score will be 0 to 1, and higher values indicate better clustering. F1 score. Okay, so there is something called a precision and recall. Before we get into the F1 score, there is something called a precision and recall. What is the precision? Precision is equal to true positive divided by true positive plus false positive. Recall is something which true positive divided by true positive plus false negative. This is the precision and recall. The F1 score is equal to 2 into precision into recall divided by precision plus recall. This is the F1 score. 0 and 1. Higher F1 score implies better clustering performance. Okay. So there is something once again, F1 score is based on precision and recall. What is precision? Precision is true positive divided by true positive plus false positive. Recall is equal to true positive divided by true positive plus false negative. Okay, so the higher F1 implies better clustering performance. Finally, we also do have something called Fox-Mallows index, FMI. Again, evaluate the similarity of clustering assignments to the ground truth using the geometric means of precision recall. Here also we'll use precision recall. FMI is equal to square root of true positive divided by true positive plus false positive into true positive divided by true positive plus false negative. Again, the range is higher values indicate better alignment with respect to the ground truth, and all the clusters have been rightly identified. These are the performance metrics for the clustering methods. Thank you.